Hello, welcome to Mickey Tiki. Learn as engineer, teach as champion. First of all, I would like to thank my family for their continuous support and encouragement of creating these kinds of technical videos in public domain. And I would like to thank my mentor, Professor R. Surendran from Government College of Technology, Coimbatore, for igniting me a spark of creating these kinds of technical videos in public domain. I would like to thank Almighty my God for my good health and broad mind, and I would like to thank my friends, followers, my dear students, and subscribers for their continuous support and effort. Today's topic of interest is dimensional analysis. So, the dimensional analysis is a very superb concept that gives a relation between two variables involved in a physical problem, or we can say if any physical phenomena is involving with n number of variables, the relation between those n number of variables can be formulated by means of this dimensional analysis. So, the unknown physical problem can be unknown physical problem, or the unknown relation between the variables involved in the physical problems can be solved by means of this dimensional analysis. So, here we have to know the dependent and independent variables. That is enough for finding a relationship between the variables. So, with this introduction, I would like to move on the dimensional analysis. First, we have to ensure that in dimensional analysis, the dimensional homogeneity is a important thing. That the dimensional homogeneity illustrates uh, when the dimensions of left hand side are same as the dimensions of the right hand side in the equation is said to be dimensionally homogeneous. What is meant by homogeneous? Yes, we know that is same at everywhere. So here the dimensional homogeneity gives the right hand side units is equal to left hand side units. So the dimensions, right hand side dimensions is equal to left hand side dimensions, which means I would like to quote an example like we know that pressure is equal to, as per hydrostatic law, rho gh. Okay, so we know that the unit of pressure is Newton per meter square, where the density is kg per meter cube into the gravity, we know that meter per second square, and height we know that in terms of meters, and we know that kg meter per second square, which is nothing but a newton. So newton per meter cube into meter is the unit. Here we just cut these terms, therefore newton per meter square is equal to newton per meter square. So if I can say this equation is valid since it is having a dimensional homogeneity, so this is our interest about the dimensional homogeneity. In every equation you can take, it is supposed to be an dimensional homogeneous. Okay, so we know that the stress is equal to force by area. We know that force is equal to newton per meter square, and so sorry, force is equal to newton and area is the meter square. Therefore the unit of the stress is newton per meter square. Here the opposing the formula is newton per meter square. So the equation is dimensionally homogeneous, then only it can be valid. Okay, if you can take all the equations you have studied in the mechanical engineering, you can see that all the equations are dimensionally homogeneous, then only the equation is being valid. Okay, so with this we know that the dimensional analysis can be done by two types. One is Buckingham pi theorem, then another one is Rayleigh method. Rayleigh method. In Rayleigh method, the physical phenomena involving variables is not more than two. So more than two variables involved in a problem. If we are interested to solve in Rayleigh method, it is been tedious. More number of iterations we have to do in order to get the solution. So that is why the Buckingham invents the pi theorem. That is why we call it as a Buckingham pi theorem. It states that if there is an n variable in the physical phenomena and these variables contain m primary dimensions, we know that primary dimensions are mlt, then the variable quantities are arranged into n minus m dimensionless groups. So that is called as a pi terms. We know that if any physical phenomena is having, I can say it is involving six variables. We know that the m fundamental variables are three. That is m, l, t. So 6 minus 3, which is nothing but 3. Therefore, those phenomena, those problem is having three pi terms. The pi number of pi terms is 3. Number of pi terms is 3. So we have to find pi 1, pi 2 and pi 3 to get a relation between these pi terms. So if you can see with this background, if you can see any problem, you can easily understand that problem. So here I will like to quote some of the fundamental units and the dimensions, how it is being developed. We know that the mass, it is kg, so that is m. In ml theta system it is m. You have to notice these terms only, so this and this. So this is for your extra information. So the basic variable, these are the basic variables. So basic variables: mass is kg, length is meter, time is seconds, force is newton, temperature is in degree celsius or kelvin. So the mass is m. Mass is denoted as m. Length is denoted as meter, that is mlt system l, and time seconds and t, and force newton, that is kg meter per second square. Therefore mlt power minus 1 minus 2. Therefore temperature, it is theta. So I can easily say that ml by t power 2 t square is equal to ml t power minus 2. I can say in this manner. Okay. And next, area. So these are all the geometric properties. Area meter square, that is l square. Volume meter cube, that is l cube. Volume rate of flow meter cube per second, that is l cube t power minus 1. Mass rate of flow, that is kg per second, that is m t power minus 1. Velocity meter per second, that is l t power minus 1. Angular velocity radian per second, that is t power minus 1. And next, force is a newton, ml t power minus 2. And pressure or stress, or we can say bulk modulus, elastic all the elastic constants are, the units are newton per meter square. mlt system, that is m l power minus 1 t power minus 2. And moment, it is newton meter, that is ml square ml square t power minus 2. And work or energy, that is also newton per meters, newton meter or joule, ml square t power minus 2. And power, that is watt or joule per second. Therefore ml square t power minus 3. And some of the another variables: density kg per meter cube, that is m l power minus 3. Dynamic viscosity, it is kg meter per newton second per meter square or kg per meter second, that is m l power minus 1 t power minus 1. Kinematic viscosity meter square per second, that is l square t power minus 1. Surface tension newton per meter, that is m t power minus 2 specific heat joule per kg Kelvin, that is L square T power minus 2 and theta power minus 1. Thermal conductivity watt per meter Kelvin, that is ml T power minus 3 theta. And similarly the convective heat transfer coefficient watt per meter square Kelvin, that is m m T power minus 3 theta power minus 1. The coefficient of thermal expansion, that is per degree Kelvin, that is 1 by theta. Here it is theta, 1 by theta power theta, that is theta power minus 1. Okay, next is an important thing in the Buckingham Pi theorem, selection of repeating variables. Here the repeating variables are plays a vital role. Here all the pi terms are been written as the pi term 1 is equal to a b c. So power uh, p1 q1 and r1 into d. So this is the repeating variable, and this is the another dependent variable. Okay, so the repeating variable and the powers of the repeating variable. This repeating variable you have to select as per the procedure mentioned here. For selecting the repeating variable, you should follow or you should consider the following things. That is, none of the repeating variables should be dimensionless. If in our dimension variable, independent and dependent variables, if there is a strain, it is unitless. So our dimensionless numbers, we have say Reynolds number, Mach number, we cannot take that as a repeating variable. The two repeating variables should not have the same dimensions. That is, we have a length and we have a breadth. We could not choose both as a repeating variable, since any one can be a repeating variable. And next thing is, they should not form a dimensionless group. So the selecting of repeating variables, it will not form a dimensionless group, it should form a dimension group. Okay, and select next last procedure is, dependent variable should not be considered as a repeating variable. Yes, the dependent variable should not be considered as a repeating variable. That is very important. So as per this, the repeating variable, as I said, a b c, one is having geometric property and another one is having a fluid property and another one is having a flow property. So that is an important geometric fluid and flow property, or we can say geometric flow and fluid property, whatever may be. So these terms are the repeating variables, or these terms are the repeating variables. As I said, if in a physical phenomena, there is a length involves, there is a velocity involves, there is a discharge involves, there is a breath involves, and there is we can say what not. Okay, if we say this, uh, and viscosity is involves. Okay, viscosity and density is involves. We can say the geometric property, we have select the length, and the flow property we can select a velocity. So this is geometry, this is flow, and this one is a fluid property. So if we can compare this length and breadth, either we have to take any one parameter, the whichever the parameter have a maximum functional capacity, we have to take. So we have to analyze the problem and we have to take either length or breadth, whichever will going to involve a lot, that we have to choose as a geometric property. And flow property, we have a velocity is there, discharge is there. We know that for finding discharge, it is area into velocity, therefore, and another one term is coming, therefore here the discharge may not be a flow property because velocity involves. the velocity can be a flow property, so we have to choose the velocity as a flow property. And similarly, the viscosity as well as the density, here we know that density is the primary fluid property, and viscosity we can say it depends on the density or temperature, we can say. So the density is the primary property of the fluid, so we can take density as the fluid property. By selecting these geometric flow and fluid properties, we can easily select the repeating variables. So, with this, I'm going to stop today's lecture. If you have any doubts, please let me know in the comment section. I will put in another video for clarifying your doubts. And if you like my video, please do like, share, and subscribe my channel Meki Techie with Santosh for continual update of mechanical engineering. So, with this, I would like to give, I would like to say again, a thank you for patient listening. Thank you all.